Hello, and welcome to the second try of this welcome video for Space Exploration Leaders Level Up Facebook group. My name is Jeff Nosanov. I worked for NASA for 10 years, and in this group and some other materials, I want to basically tell everyone who's interested how space exploration really works, go kind of between the lines of media reporting, on which sort of just discusses what happens and sometimes doesn't even get that right, and really explain the why and the how of how we explore the universe and what's going on in the world today in space exploration, which is quite a bit, and it's really much more diverse and interesting than it's ever been. So I hope to capture and build on your interest. What you're hearing back there is my two kittens who are doing their best trying to ruin the blinds. They'll probably come along the shelf here, but do not be alarmed. That is not a glitch. That is a feature of this live, that kittens make noises during it. So I also want to talk about the recent SpaceX test. And there's, it's been enough time since then. Okay, there's one. Hi. It's been enough time since the test that a lot of the rumors have sort of congealed into some plausible explanations. And of course, we're not going to know for sure why certain things happened. I get right into that. Basically, it looks like the rocket failed because, well, it was a complete success from a mission point of view in that it actually flew and it cleared the launch tower. But basically, they used such an inadequate launch pad that the engine exhaust destroyed the launch pad and blasted a bunch of debris upwards into the engines themselves, damaging many of them. And you could even see that from the launch itself. There were several shots of it when they showed the rocket from below, and 4 or 5 of the engines were dark. So that's not good. But what's amazing is that the whatever computer and fuel control systems are there actually kept the thing going straight up, more or less. So that's actually an incredible achievement. One of the reasons no one's ever really attempted this many engines in a rocket before is that challenge of keeping all that plumbing flowing fuel to engines. And for it to work so well despite damage, it's really amazing. So I think it's a complete success from showing that you can start to control a rocket like that, and you can build it out of steel, which is also new. So complete success. Now, the next question is, why did they launch with such an inadequate, really a comically inadequate launch pad? And that's where the rumors get harder to separate, because they must have known that the launch pad was inadequate. And given that the goal was just to fly the rocket in the first place, the launch pad, the goal was just to fly the rocket in the first place, but the insufficiency of the launch pad could have easily ruined that. So that's the strange thing to me, and I think that the various commenters out there, no one's really quite sure what the logic was. Again, it was never supposed to do anything more than just take off and fly a bit, but that could have easily failed because of the launch pad. So among the rumors are that SpaceX has been designing a launch pad for 2 years already, and wow, lots going on in here. And they couldn't build it in time, and that they really wanted to test the rocket. That's possible. Well, it was 420, and Elon Musk is a fan of the imagery there. I'll put it that way. So maybe he just wanted to launch Light 33 engines on 420, and that was good enough. I don't know. It's hard to guess how he makes decisions like that. But anyway, it's hey John, it's a really interesting story, and I don't know when we'll get real answers. But the launch was a complete success, and they will need a new launch pad. There's even rumors that they didn't care that it would destroy the launch pad because it was cheaper than demolishing it. And if that's true, well, that's pretty wild. I don't know. The launch pads are not the hard part of the rocket science, typically. But in this case, who knows? So hopefully that's interesting. Not the most satisfying of rumors, I think, because they basically all come down to the total mystery of how Elon Musk thinks and makes decisions. But hopefully that's a little bit of clarity on why on what happened last week. So I'll give a little more background. Normally, one of the things Elon Musk did from the beginning with SpaceX is really challenge the way that rockets are built and tested. Normally, you don't publicly blow up a rocket or even launch it if you think it might blow up. And that results in very long development times and huge, or rather very, very low tolerance for risk and much larger budgets and so on. But what Elon Musk has done from the beginning is really shown that he doesn't care about blowing things up, and that it does in fact get a reliable rocket to the launch pad and ultimately to the customer much faster than the other way. And as the rockets he builds get bigger, it seems harder and harder to fathom that that's the way that he approaches testing. But it really has worked. So even with this giant steel mega rocket, that seems to be the underlying methodology. And looking purely from an evidence-based point of view about his previous rockets, there's no reason to change it. As counterintuitive as that seems, to see such an expensive rocket explode when you might think, well, it didn't need to. So that's really, I imagine, his thinking behind it. But we'll see. I mean, the first time he started testing rockets like this, SpaceX had no money and no confidence. So they really did come close to bankruptcy after several tests. But what Elon Musk decided at the time was, well, this business wasn't going to survive or last long enough if he couldn't accelerate the testing. And so it was worth risking that because it wasn't going to work anyway if the testing was too slow. So again, from an emotionless point of view, I can see the rational thinking there. And it worked this far, so we'll see. Now, looking historically, one of the things he may have looked to is the early rocket tests of the 40s and 50s. Okay, here's the kitten that she must have just finished destroying the blinds. So this is Thing. Say hi, Thing. Okay. So back in the day, of course, they had no choice but to blow things up all the time when they were testing them because they didn't know any better. It was all brand new. So NASA would actually pay for that. And one of my favorite stories from the history of JPL is that in the Apollo era, when JPL was building, one of their goals in the 60s was to put a camera on the moon and broadcast back to Earth. And that involved launching from the Earth, getting to the moon, landing a camera, turning it on. And basically every one of those steps failed 2 or 3 times along the way. And they didn't get a working camera on the moon until maybe the 8th or 9th try, something like that. And every time it would blow up a little farther, or it would fail a little farther. It would blow up on the launch pad, then it would blow up in flight. Then it would get to space but not leave the Earth. Then it would get to translunar orbit and that would fail. And then it would get to the moon and crash and so on. And then I think the second to last time that landed and the camera broke. And every time they went back to NASA and said, hey, we need another, whatever it was, $500,000 at that time. And NASA gave it to them, and they didn't waste time. And that was part of getting humans to the moon with Apollo. It's not often told as part of the story because it was purely robotic, but it also was it may have been the first soft landing on the moon ever. So pretty important piece of it. But Elon Musk, if he is informed by history in this way, I don't know if he is, he might think, well, it worked well enough the first time, really the first 30 years of this stuff. And so maybe that's how he thinks and says, well, we can keep doing this. And it works. So unclear. Another interesting thing about him and SpaceX from a business point of view is that because most businesses, at the time at least, that provide launch vehicles, because most of them, well, all of them worked the old-fashioned way where you minimized risk. You didn't, your biggest nightmare was a public test failure. There was actually a huge opportunity to disrupt the market with a different way of building rockets. And so that was one of the things that Elon Musk does. I'll probably end up mentioning that in a lot of videos, but basically the traditional aerospace industry until him worked by having lots of component suppliers all over the country, distributing taxpayer money to lots of different districts, and it was very slow. And but of course, from the company's point of view, it allowed kind of endless extraction of funds from the U.S. government. And what Elon Musk decided in the beginning of SpaceX was we're going to build everything in house. We're going to test rapidly, fail quickly, and redesign. And it's really it feels so strange to talk about Elon Musk in this way now because he's such a controversial figure now. And again, something I'll probably say a lot. But he really did reinvent the way we design rockets, or he showed that a different way of designing rockets can work both technically and economically. So that's sort of the top level summary. I see we have 2 viewers. Does anyone have any questions? Well, while we're waiting for that, while we're waiting to see if anyone has questions, I'll talk a little bit more about what the group is for. Oh, hi, Brandy. Yeah, trying to think of new ways of doing things. I mean, if you go back even farther with Elon Musk, he after he, I think it was after he sold PayPal, or maybe it was his previous company. He literally flew to Russia and tried to buy a rocket from the former Soviet space program because he wanted to start a launch service here, and you need a rocket to do that. And they basically laughed him out of the room, even though the Soviet Union had, or that Russia had tons of former Soviet equipment sitting around. I mean, to this day, old Russian rocket engines that have been kept in cold storage are sold on the global market because they were just that good, even though they've been sitting in the cold for 40 years or 30 years. Anyway, he thought he could go over there and buy himself a rocket and start, um, buy low and sell high, so to speak. And they basically laughed him out of the room. And he said all this in a CNN or a 60 Minutes interview a while back when he was a purely inspiring and sympathetic figure. He was near tears in this video about talking about how he was so upset by these these old Russian guys laughing at him basically, and so that seems to have really inspired him. And of course, if there's one thing that's more old-fashioned than the aerospace industry, it's the Soviet aerospace industry. So that kind of all led up to last week's test, and we'll see where it goes from here. I mean, if they have to build a new launch, well, so they are definitely building a new launch pad in Florida. This test last week was from Texas. I don't care if they destroy the blinds over there because they're like they were pretty old when we moved in last year, so kind of inevitable. Kind of like Elon Musk destroying the launch pad so he didn't have to demolish it. I'm going to let the cats destroy the blinds so I don't have to do it. Now that would be a pretty wild rumor if they knew it would destroy the launch pad and they decided to save a couple $1 million of demolition. I even not knowing Elon Musk, even seeing Elon Musk, I can't go that far because that could have easily took out destroyed something critical before it even launched, and that would be truly pointless. So much of Elon Musk's behavior is bluster and for show, but I think he did need that. He did need that thing to take off. And of course, if you have a bunch of concrete chunks flying into your engines before they even leave the ground, that could really limit that. So my guess is somebody was a little too cocky and said, no, it can't be that bad. And technically they were right because it did fly much farther than it could have with significant damage. But it was ultimately a successful test. Although, again, just like how when he smoked pot on Joe Rogan and brought himself a whole bunch of unnecessary, regulatory attention and so on, the destruction caused by the rocket and the launch pad did damage some nearby properties, and that is going to make it harder for his next FAA approval. Oh, so the kittens are practicing over there. Yeah. Hope you enjoyed that. Um, uh, anyway, so that's where we are with Elon Musk. And No, it probably should not have. That's a great question. So the fact that three or five or six of the engines were not on when we first saw the rocket from underneath. Uh, no, it should have taken longer. I mean, it should have taken less time, and that's because a quarter of the engines weren't working. And any normal company, any normal company would have designed a rocket to just not try if it detected even one engine failure. But Elon Musk must have said at some point a couple of years ago, there's certainly a number of rockets of engines without which it's impossible to take off. So I'm sure the thing would have been designed to just quit and power down or something if that number of rockets were offline. But someone made the deliberate decision to program it to take off with at least the minimum number of engines and balance the force of each engine in some way, because each engine is individually gimbaled, meaning it can turn to some amount. So that's yet another layer that is truly unprecedented and an amazing achievement. Um, and with that many engines, they each need to be individually gimbaled so that the thrust in the rocket can go the right way. I mean, if you consider this canned air as a rocket, if there's 33 individual engines down there, um, the rocket either needs to have some kind of control surfaces like fins to tilt it, um, but then you have a problem of 33 engines pushing down, and then way up here on the other side of the center of mass of the rocket and what we call the center of thrust, the point on the rocket body where the thrust vectors, the lines coming out of each engine, add up. Then you have to control the airflow way from there. So generally, it's worth the work to make all of those rockets turn a little bit. And they did, because they had to counteract for it. There was at least three engines on one side I saw. Maybe it was like five. There were like three here and two here that weren't working. So that's a huge off-center amount of thrust if you think about it. If this side engines are not working and these are all pointing down, the thing is going to go like this. But they got off the ground and then adjusted. So really quite amazing. I know I keep saying that, but it's sort of on and on with like it's so Elon Musk. It's like so hashtag Elon Musk to like so characteristic of him that they would build something so amazing and then launch it without a launch pad, even though they probably knew, or somebody there must have told them. Because even if he didn't know launch pads, which I'm sure he does, you know, he hired a guy named Tom Mueller, I think is his name, from Northrop, I think 20 years ago, probably the greatest rocket scientist since von Braun. Um, Certainly one of the most experienced humans alive in the mass manufacture of reliable rocket engines. So he certainly knew about launch pads. So whatever calculated risk they took was extremely bold. Any other questions? So there's two viewers. I see Brandy's one of them. John, if you're the other one, I really appreciated you two here to join me on this. Now, one thing that would have been really cool to see is the stage separation, because there's more of those engines on the second stage. And thank you. And I should say there's fewer of those engines on the second stage, which would be like this part of it, than there are here, of course, because this whole thing is gone. Or in theory, this thing will separate and then this will go and land somewhere. But I mean, I think they showed the reliability of the methane rockets, or rather the methane engines, simply because so many of them kept working, and the plumbing that kept them all fueled clearly kept working, and even shut off the fuel to the ones that weren't working, because otherwise that would have gone over pressure and something bad would have happened. So yeah, truly amazing. I mean, in so many more ways than usual, because you have an incredible technical achievement and an incredible technical oversight in the launch pad, and yet the technical achievement still worked. And then the decision to take the risk on trying out all these new things with an oversight that must have been acknowledged, must have been known. So, you know, it's tempting to say Elon Musk does it again in a way, but at this point it's probably more his team. I mean, a lot of people question who's really making the engineering decisions. I mean, Elon Musk is a self-taught rocket scientist to great effect, but at a certain point, someone else is really, I think, driving the major decisions according to his business goals. And I suspect he made the business goal to lower the cost of the launch by using steel in the vehicle, and then that drove the move to methane engines because they have more thrust basically. So I'm sure he was involved somewhere in the engineering, but I think that's where his decisions were made because nobody but him would have decided to do this way because nobody but him has the sort of supernatural confidence and well, frankly, the financial wherewithal, or at least the attitude about finances to do things this way and take this risk. But I do think it was successful. Okay, next question. Even though there was no second stage separation, I figured there would have been some sort of escape test when the rocket started flipping to remain attached. Is the thing that releases the second stage also what would release an emergency breakaway? Sure. So you're talking about an abort system or an escape system, like, well, like the SLS has, and of course NASA is not going to certify for crewed flight a rocket that does not have an escape system of some kind. The space shuttle didn't, and obviously that led to several tragedies. And they knew that going in. Um, Typically, I'm trying to remember what the SLS escape system is. Basically the crew capsule pops off, flies away, and parachutes down. And stage separation is usually done with explosive charges that force the two parts of the rocket of the system away from each other, because when the upper part's engine's light, you really need the bottom part to be as far away as you can. Now, I was reading somewhere that this vehicle is going to use actual sort of a momentum-based approach. So basically, instead of blowing them apart the way I just described, a slight roll will be established, which will actually, what's the word? Centrifugally force them apart. And I don't know if that's true. Certainly would be an interesting approach. It would achieve a lot of distance between the lower stage and the upper stage. And there are reasons you might want to do that, because most rockets before this one, the bottom stage was just garbage the moment it's separated. But of course, this thing has to come and land. So you don't just want to blow them apart as fast as possible. The idea of a momentum-based or centrifugal separation may be to maintain some level of control between the two parts so that the bottom part can land and the upper stage can keep going. Unfortunately, with all the damage that was definitely sustained because of the launch pad exploding, it's hard to see from the outside. It's hard to guess from the outside what that failure was. It's a good thing that the engines did not ignite without it separating, because that would have, well, I guess it would have just blown it up sooner. But every single step and every single component involved was generating data the whole time, and that will let them avoid these problems in the future. So I'm sure somewhere in that data, maybe nobody has figured it out yet, but there will be a good explanation. Someone will be able to come up with an explanation for why it didn't separate. It's also possible that the system was working fully as intended, and because so many engines failed, and because it wasn't going at the right speed, it would have. Oh yeah, that may be a. If you imagine a world where these things are routine, where rocket launches like this are routine, and a system like this works every day the way aircraft do. An aircraft with 4 engines can fly with 1. Not as fast or as high, but it can. There's engineering safety factors 300-400%. So things just work, and safety is a relative non-issue. With a rocket, even the most reliable rockets, I don't know that you would say there's that much safety built in. But you can imagine if you have 33 rockets, 33 engines, you need them. The thing can certainly fly without all of them. And there's some limit. There's some point at which the system can account for failed engines or underperforming engines or whatever. And if you're in a launch, let's say these things are launching once a day, a couple engines fail, you have to adjust the later stages of your mission. So you have to separate later at a different altitude and higher velocity. So it's possible that's what was happening, because when they said on the broadcast, the announcers were saying, "Oh, we should have separation any minute, any minute." Well, it's possible the software inside the rocket was aware or had measured that it was at the wrong. It had measured that it was at the wrong velocity for its current altitude that would have allowed it to separate on a normal launch, and so it didn't. And then they terminated it anyway, so it didn't matter. But it's certainly true that if you're flying something like this and you have some small deviation from your normal altitude and velocity, you certainly can't separate at the same time as you would normally. I hope this is clear. You've never had that flexibility in a rocket launch before. So it just occurred to me while I was talking a minute ago, because normally there's almost no room for error. They can throttle up or down the engines, but you certainly don't have multiple engines doing different things and accounting for each other. That has never been a possibility before. So again, whatever control system was implemented to make all these things happen has to have the additional complexity of saying, oh, are we at the right altitude and the right velocity, and well, the velocity including the direction. And if not, do we either auto destruct, or do we have this and that engine, adapt, and then separate later? So this is all speculation, but those choices certainly have never been possible before, and they're all done by a computer because no human could possibly react fast enough. Well, maybe Elon Musk would have the balls to drive that thing with an Xbox controller, but certainly not with a customer having paid for it. So yeah, that's some more thoughts on what could have been happening. I mean, one of the things about all this that isn't usually seen by the public is the huge amount of software testing. And at JPL, we had huge buildings full of hardware, not full of, but very large facilities where spacecraft control software would be tested under millions of different configurations and scenarios on a regular computer, and then it would be tested on a space qualified computer, and then ultimately used in the mission. I had less exposure to that, but one of the really interesting things about computer science that is sort of a tangent here, but all these things are in theory deterministic, meaning something goes in and something goes out, and that's predictable. So one of the reasons that deep space hardware works so well is because the software that makes decisions in flight and on the ground of other planets is so ridiculously thoroughly tested that it's rare there's a real world scenario that has not been probabilistically identified and tested. Again, I should do a podcast with someone who knows that stuff better, because it's pretty interesting, and nobody ever thinks about it. Usually we think about the physical spacecraft you can see, and sometimes you see 33 engines and you're like, wow, there must be a really advanced computer program running that. But the computer program running on the rover on Mars right now, I doubt many people put much thought into that, but it's a remarkable thing, because in a moment of being philosophical, you could almost argue it's sort of like a living thing out there, because it has to keep itself alive, keep itself fed, sort of, with its resources like light and electricity and stuff. I'm not saying the Mars rover is alive. I'm saying the further away we send things, the more, the easier it is to project emotionally, like a sense of living thing, a sense of life onto it. But the rovers on Mars have to be able to make a lot of decisions for themselves that protect themselves, kind of like the kittens. I don't know whether 10 years of rover development or 10 or a billion years of evolution do a better job of evolving self protection. Um, Sometimes I look at the kittens and I think, 10 billion years of the universe, 5 billion years on Earth, and we got that. But they probably think the same when they look at us. Anyway, the lines get kind of blurred, I think. And the more we explore the universe, the farther those things are going to get pushed. As eventually we're going to have robotic systems so far away that we couldn't even control them if we wanted to because the speed of light is too slow. So, yeah. I mean, another thing that's often underappreciated is that the autonomous software technologies that spacecraft use do end up kind of getting industrialized into other products and industries through a technology transfer process. So it's not, this is on, some people think NASA is pointless and a waste of money. Well, a lot of technologies we use every day have come out of NASA. That's a particular sticking point for me. I could talk about it another time, and I've been through the technology transfer process myself for one of my other companies. And anyway, that's kind of a tangent upon a tangent. So we're getting close to about 5 minutes left on this. Happy to answer other questions or continue kind of letting my mind wander. I like this. This is working well with the kittens in the background. I think it adds a certain humanity to this topic that's otherwise pretty abstract. I mean, I really do think sometimes about how just the great diversity of life on Earth and human experience and where we are going and the things we built as a species. And at the end of the day, we're only slightly more advanced than those two. I did have the idea once of doing a podcast for charity where I talk about space for 24 hours straight without stopping, and my friend who's also into space was going to join me. I haven't had 24 hours straight to myself since I became a parent 10 years ago, almost 11 years ago. But someday I think that'd be a fun exercise, maybe when there's a much bigger audience to raise some money. Talk about space for 24 hours straight. There's a funny YouTuber who did this thing where he watched grass grow for 10 hours straight and he watched ice melt for 10 hours straight, and apparently got millions and millions of views and raised money for charity. So if people will do that, people will watch that. I think they would watch two nerds talk about space for 24 hours straight. Certainly would not run out of subjects. It'd be pretty funny for the last 6 or 8 hours too, as you try to stay awake and get into even more obscure topics. Yeah, actually, I was looking up marketing information, like top searches about NASA, and a huge number of people are Googling, "What's the point of NASA? Why are we doing this?" And I think that's a really interesting question. And if you asked that question in 1957 when NASA was formed, the answer would be obvious. It would be closing the capability gap with the Soviet Union and exploring. But then you have 2 or 3 generations born since then. And when you already have a sky full of satellites and a solar system full of robots, it's really easy to ask, what's the point of space exploration? Because you weren't there to see to quote Jeff Goldblum in Jurassic Park, because you didn't see the discipline it took to achieve it. Or that's not quite the line, but I hope I can use this platform to answer the question of what's the point of space exploration. I'm going to do a video at some point on the different national programs to build outposts at the moon. What would it mean if at the end of the 21st century, China had a thriving presence on the moon and we didn't? Would that mean anything? It does seem like China is trying to reproduce the Apollo program achievements and for some of the same goals. And even if we in the US decide that is not necessary, well, what does it mean if someone else does decide that that's necessary? Someone who may be more of a peer in power. as the century goes on. So yeah, I think it's questions worth asking. Um, NASA hasn't done itself any, I should say, Congress hasn't done NASA any favors in that regard, as the administrator of NASA vehemently supports the ban on partnership with China, the NASA partnership with China, which when I worked at NASA was a big no go topic. But I don't work for NASA anymore, so I can talk about how dumb I think that is, and how all that's going to do is create um, secrecy and power asymmetries that we may not know about. Now, I say that as a civilian having no knowledge of sensitive or classified information, but I do think that the gap is closing, and even if we were to try to keep it from closing, that's not the most effective way to do it. But it plays well, and it's the status quo, which makes it harder to harder to deviate from. Anyway, so we can talk about that too. And certainly, we're going to talk about the moon to Mars plan that NASA put out the other day. And I got the whole 150-page document and the summary. Well, I'll probably do a video on the summary first, and maybe reference the whole document. And that's a really big topic, because it goes into how NASA makes decisions, which again is a big part of what I want to share on this platform. We don't partner with other countries, but we recruit from them. Technically, if you're a Chinese citizen, is going to have a hell of a time getting employed at NASA. So we certainly educate a lot of people from all over the world, but China, Cuba, North Korea, Iran. If that's your citizenship, if that's your passport, you're going to have a hard time getting a job at NASA. So yeah, we recruit sort of nationally. And actually, a lot of people go to, oh, this is a great topic to close on, actually, because it just sort of we can get to sort of the global, kind of the global cycle of all of this. Like, for example, one of the people who founded JPL was from China, and eventually the U.S. kicked him out. So he went back to China and started their space program. I mean, it's not rocket science to think what would happen if you do that. So that was kind of an own goal, and there is a huge amount of, I mean, if you do view the world in that purely adversarial lens, yeah, they did that, and that was a pretty big own goal, and that got post World War II China starting a space and aerospace program much faster than they would have if they had to do it internally. And frequently we educate, universities educate people who then can't get work in the U.S. and go back to their countries and start, and contribute there, which in theory is a wonderful thing, and kind of the utopian world some of us might want to exist. That would be an unquestionably great thing. But because of the way the rules of immigration and technology protection and export control, because of the way all those things work or don't work or overlap or not, there's a lot of ways. And because universities prefer foreign students because they pay more, there's all kinds of incentives to basically take someone from another country, make them an expert, and then kick them out in this country. And to solve that problem, you have to reform immigration and higher education. So good luck. So these are crazy things in our system that not going to be easily resolved. But that's humanity. That's life and history. There's never been a time when there weren't crazy, strange things like that happening. So with that, I'm going to end this welcome video, and thank you both for joining. I guess I will pin this and leave it up, and I hope it was really interesting. And as always, leave comments in the group for topics to discuss, and I'll set up another one maybe later this week when I've gone through some of the recent developments. So thanks, everybody. Have a great day.